Hello, and welcome to the Sammy overview session where we're going to take a deep dive look into the thread dump analysis viewer. Thread dump analysis is supported for Windchill, ThingWorx, and the Integrity product and profiles. We support various formats and collection methods. For this session, I will be analyzing various Integrity, ThingWorx, and Windchill thread dumps. In general, the overview here will apply to all three products. Let's quickly take a look at a raw thread dump file. As you can see, it's all text-based and can be quite large. Sometimes it can be very difficult to find the problem in here. It can require a tremendous amount of time and effort. Now let's load a thread dump file into Sammy, and we'll take a look at what it generates. So as usual, it presents you with the analysis report. We're not going to focus on the results here right now. Instead, we're going to select the Stack Trace tab on the left here. And what we are presented with is a graphical representation of the thread dump. On the left-hand side of this view, we have a list of the files that were in this analysis session. In this particular session, there was only one file here. So I'm going to hide that view so we can focus on the stack trace. I'm also going to open up the legend view on the right. This view shows us what all the icons signify and allows us to filter on them, which we'll cover shortly. One thing to note about the legend is these icons are product specific. So if you're analyzing a Windchill thread dump or an Integrity thread dump or a ThingWorx thread dump, you're going to see different icons here, different states. Now let's take a look at our thread dump graphical view. On the left, we can see the thread names that were captured in the thread dump. And at the top, we have a list of thread capture IDs. So this thread dump session had 17 captures in it that we have analyzed and put together. Each cell in this table represents the thread state per thread dump capture. As you can see, we annotate each cell with colors and icons that correlate to the thread state. These icons and colors can be referenced in the legend on the right. We merge cells together when the thread state has not changed. That is the thread call stack and the CPU time. This allows you to quickly see which threads are stuck in certain areas of the code. We can enable tooltips for the threads up here at the top. And then as we hover over each cell in the table, we get a pop-up with the actual thread state content. If we take a look at a thread as an example, here we can see the raw text details that we would see in the normal thread dump file. And what we have done is we have highlighted the patterns that were matched in order for us to identify the special thread states. So in this particular thread, we identified this get issues call for the Integrity product. And then later on, we identified a database read. We take these matched patterns and we construct a breadcrumb at the top here so you can quickly see what the thread is doing. So for this particular thread, we can see it was performing an Integrity operation, specifically a get issues call, and it was currently reading from the DB. This can really help speed up the thread analysis because you can hover over various threads to see exactly what they're doing. Coming back to the legend, we have three different categories for these annotations. The first one is thread types, which are threads that are created for a specific purpose and do not change. So in this example, we have web threads and LDAP threads. We also have thread states, which are a given state at a point in time. The thread state can change over time for the same thread. And finally, the consistent thread states. These states are disabled by default because they have been identified as not progressing and are generally speaking not the threads you're looking for. So to show you an example of this, I'm going to disable all of the filters, and then I will enable only consistent thread states for the runnable type. So here you can see these LDAP threads have not changed from the first capture all the way to the last capture. That means the CPU time has not changed as well. That's why we merged the cells together. And all of these threads are, generally speaking, not very useful. So as you've seen, you can filter the view based on these thread states. I'm going to go back to the set of defaults here. And let's say I only want to see database operations. I can uncheck these other filters, and I can hit the update button. And what I'm presented with is a list of threads that have at least one database read or database write captured throughout their entire thread dump capture. We also have some additional filters up here that are text-based. You can click the plus sign here to create the new filter, paste in whatever criteria you're looking for, select add filter, and it'll filter the results even more. So these results here are database reads or database writes that are matching this queries filter. And if I take a look, we can see all the various text here that match that filter. These filters can also be inverted. So instead of the default inclusion mode, you can change the mode here for an exclusion mode. And now those threads have been removed from the list. I'm going to go back to our defaults here. So select the defaults for our thread filters. And up here, I will remove these filters as well. And now I can sort the list based on various options. So by default, it's sorted by chronological order, so the order that the threads were created. I could sort by thread name if I want. You can see there, you get all these beep threads first. Or I can sort by CPU time. So the threads up here are the threads that have used the most CPU time. I can enable the show values as well, so you can actually see the values that we're sorting on. There's also user time and bytes allocated. And finally, the delta mode is where we calculate the difference of CPU time or the bytes allocated from the first capture to the last capture. If you're not using delta mode, it's going to just grab the last value in the last capture. All right, let's take a look at some of the other views that are offered here. So up until now, we've been looking at the table view. There is also a standard thread dump view, a sequence view, which shows you the progression of a single thread, a histogram view, which shows you the hotspots, so which thread call stacks were most frequent in the entire thread dump capture, and finally the lockers view, which shows you an object locking hierarchy. So we'll take a look at the thread dump view first. This should look fairly familiar. It's basically showing what you would see in the actual text file, with, of course, the difference being our highlighted annotations, which you can see here, and our icons with the breadcrumb as well constructed. On the left-hand side, you can select the different thread dump captures. So as we've seen, there was 17 of them. Here you can see the different time frames. And you can actually reanalyze the session if you like. So if you find that you only want the last 6 different captures, for example, you can select that range, reanalyze it, and you'll only see those 6 captures. Moving on to the sequence view. Here we can see the threads and how they've progressed for each capture. And on the left-hand side, you can select the different threads. The histogram view, like I said before, shows a hotspot of which thread call stacks appeared most frequent in the entire capture. So we can see that these LDAP threads were sitting there idle reading for 2,858 individual threads in all of the 17 captures. This view can be really beneficial to show you where things are getting stuck, where the code is getting stuck processing. And finally, the lockers view, which shows you the thread locking hierarchy. So here we can see that this thread was runnable and it was blocking all of these other threads below it. This can be really beneficial to figure out where the locking is occurring in a server. Now I want to show you a quick example of what a ThingWorx stack trace looks like. So first thing I'm going to have to do is change my profile. So I'm going to switch it from the integrity profile to the ThingWorx profile. And then I'm going to drag a new file in that is collected from a ThingWorx server. So it analyzes the file, gives us our stack trace tab here on the left. Once again, I've only got one file in this package, so I'm going to collapse the file listing. And let's open the legend. So here we can see in the ThingWorx profile, we have a completely different set of thread types, thread states, and some different consistent thread states. But overall, the experience is basically the same. The table view renders with all the ThingWorx specific annotations. We can see the breadcrumb displayed at the top, which is very beneficial in the ThingWorx world because it pulls out the JavaScript service names, which can be very handy for analysis. Again, the filters can work against that. The histogram works the same way. So the experience is very much identical. The only difference between profiles is the states. Now I'm going to switch over and analyze a Windchill file. In Windchill, we have the ability to extract thread dumps from a Windchill server log. So I'm going to drag in a method server log for Windchill. And what we're presented with here are two tabs on the left. So we have the normal log files tab, which shows the actual content for the server log. But as we can see in here, there's actually an embedded thread dump capture. So we identify these embedded thread dump captures, and we extract them to generate the stack traces tab. In here, we can see all the thread dump captures at the top and the threads themselves on the left. The legend has its own set of states, just like the other products. And finally, in the thread dump metadata pop-up, we can see various details here about the captures. Windchill specifically has a DB session count metadata value, and we can follow this across multiple thread dump metadatas to see its progression. For Windchill, we also support cluster stacks. When cluster stacks are analyzed, we pre-process them to stitch out all of the thread dumps for the same process ID and put them together. Looking at the stack trace tab here, we can see the original 4 files that were included in my zip, and we can see a processed stacks section. So these are the extracted and stitched together thread dumps for each process ID. If we take a look at one of the original files and select the thread dump view, in here we can see the process ID changes for each process in the cluster. And if we look at our process stacks section, and again go to the thread dump view, we can see that the process ID does not change. So this can be very helpful for viewing the progression of a thread on the same process over time. And that concludes this thread dump overview session. I hope you found this useful. Thank you.